Mathematics has evolved through the contributions of brilliant minds from various parts of the world. Each country brought its unique cultural, philosophical, and scientific perspective to mathematics, resulting in diverse approaches and advancements. Ancient Greek mathematicians were known for their logical rigor and deductive reasoning. They focused heavily on geometry and sought to prove mathematical truths systematically, often blending mathematics with philosophy. Thales of Miletus is considered the first Greek mathematician and philosopher. He introduced geometry to Greece from Egypt and is best known for Thales' theorem, which states that an angle inscribed in a semicircle is a right angle. Thales used logical reasoning rather than mythology to explain natural phenomena. Pythagoras of Samos was a philosopher and founder of the Pythagorean school. He is most famous for the Pythagorean theorem and for exploring relationships between numbers and music. He believed that numbers were the essence of all things and introduced important ideas in number theory. Euclid, known as the father of geometry, wrote Elements, a 13-volume textbook that organized all known geometric knowledge using logical proofs. His work laid the foundation for modern geometry and influenced mathematics education for centuries. Archimedes of Syracuse was a brilliant mathematician and inventor who discovered the principle of buoyancy and devised formulas for the area and volume of curved shapes. He also made an early approximation of pi and invented devices such as the Archimedean screw. Apollonius of Perga was a master geometer best known for his work on conic sections, ellipses, parabolas, and hyperbolas. His treatise Conics influenced later developments in geometry and astronomy, especially in understanding planetary motion. Hipparchus of Nicaea was a pioneering astronomer who founded trigonometry and created the first known trigonometric table. He also discovered the precession of the equinoxes and significantly improved models of the sun and moon. Erathothenes of Cyrene was a mathematician, geographer, and librarian of Alexandria. He calculated the Earth's circumference with surprising accuracy and created the sieve of Eratosthenes, a method for identifying prime numbers. Diophatus of Alexandria is known as the father of algebra. His book Arithmetica introduced algebraic methods and symbols for solving equations. Claudius Ptolemy was a mathematician and astronomer in Roman Egypt. He authored the Almagest, which presented a geocentric model of the universe using mathematical tools like trigonometric tables. His work dominated astronomy for over 1,000 years. Proclus Lycius was a philosopher and mathematician who preserved much of ancient Greek mathematical knowledge through his commentaries on Euclid's Elements. His writings bridged ancient Greek thought with later medieval and Islamic scholars. Hypatia of Alexandria, daughter of Theon, was one of the earliest known female mathematicians. She edited and improved mathematical texts, such as Diophantus's Arithmetica and Apollonius's Conics, and taught philosophy and mathematics in Alexandria. Menelaus of Alexandria advanced spherical geometry through his work Spherica, which included what is now known as Menelaus's theorem. His contributions were essential in developing trigonometry for astronomical applications. Hero of Alexandria was a mathematician and engineer. He is known for Heron's formula to calculate the area of a triangle and for inventing mechanical devices like early steam engines, showcasing the practical applications of mathematics. English mathematicians, especially during the Scientific Revolution, emphasized applied mathematics and scientific discovery. They were instrumental in the development of calculus, logic, and early computing. Figures such as Isaac Newton, George Boole, and Ada Lovelace focused on using mathematics to understand motion, logic, and machines, reflecting a practical and interdisciplinary approach. Isaac Newton is best known for co-founding calculus. He applied mathematics to physics in his seminal work Principia Mathematica, where he formulated the laws of motion and universal gravitation, making him one of the most influential figures in both mathematics and science. George Boole was a pioneer in the development of symbolic logic. He created Boolean algebra, a system of logic using binary values, true or false, or 1 or 0, which became the foundation of modern computer science and digital electronics. His book The Laws of Thought revolutionized how logic and reasoning are understood and applied in computing and mathematics. Augustus De Morgan, although born in British India, spent most of his life in England and was the first professor of mathematics at University College London. He is known for De Morgan's laws, which are fundamental in logic and set theory. De Morgan played a vital role in advancing mathematical logic and was influential in shaping mathematics education in the 19th century. Charles Babbage, born in London, is often referred to as the father of the computer for designing the analytical engine, a mechanical precursor to modern computers. His work involved complex mathematical calculations, logarithmic tables, and the invention of mechanical calculators. Babbage's contributions laid the groundwork for computational mathematics and the future of computer engineering. Ada Lovelace, born in London and the daughter of poet Lord Byron, is celebrated as the first computer programmer. She collaborated with Charles Babbage on his analytical engine and wrote the first algorithm intended to be executed by a machine. Ada foresaw the broader potential of computers beyond pure calculation, including the manipulation of symbols, music, and art. French mathematicians are known for their precision, abstraction, and emphasis on formalism. They contributed significantly to pure mathematics, especially in algebra, analysis, and topology. Mathematicians like Cauchy, Galois, and Poincaré pursued elegant and logically consistent frameworks, blending mathematical beauty with scientific insight. Rene Descartes is known as the father of analytical geometry. He introduced the Cartesian coordinate system, which connected algebra and geometry and laid the foundation for modern calculus. He is famous for the quote, "I think, therefore I am." Joseph Fourier, born in Auxerre, France, is best known for the Fourier series and transform. His work in heat transfer and wave analysis became fundamental in physics, engineering, and signal processing. Evariste Galois, from Bourg-Lorraine, France, founded group theory and developed Galois theory, which explained the solvability of algebraic equations. He died young, but left a lasting impact on modern algebra. Galois theory connects field theory and group theory. It uses groups to describe the symmetries of the roots of a polynomial and provides a criterion for determining if a polynomial equation can be solved by radicals. Essentially, Galois theory allows us to understand the structure of polynomial roots by studying the symmetries of those roots using group theory. Pascal contributed to the early development of probability theory alongside Fermat. He also worked on fluid mechanics and invented the Pascaline, an early mechanical calculator. Pascal's triangle and Pascal's law are named after him. Pierre de Fermat was a French mathematician who made substantial contributions to early modern mathematics, particularly in number theory and calculus. He is considered one of the founders of modern number theory and analytic geometry. Here are his major contributions: Fermat's last theorem, Fermat's little theorem, and Fermat's principle in optics. Italian mathematicians during the Renaissance pioneered the early development of algebra, solving cubic and quartic equations and applying mathematics to art, architecture, and physics. Figures like Fibonacci, Cardano, and Galileo were practical and innovative, often integrating mathematics with engineering and design. Leonardo Fibonacci was a medieval Italian mathematician best known for introducing the Hindu-Arabic numeral system to Europe through his book Liber Abaci. In it, he presented the famous Fibonacci sequence, a recursive series that appears in natural patterns. His work helped shift Europe from Roman numerals to a more efficient decimal system. Geralamo Cardano was a Renaissance-era mathematician, physician, and astrologer. He made significant advances in algebra and was the first to provide solutions for cubic and quartic equations in his book Ars Magna. Cardano also laid the groundwork for probability theory and explored the concept of complex numbers. Galileo Galilei, though widely celebrated as a physicist and astronomer, also made major contributions to mathematics. He applied mathematical analysis to motion and mechanics, establishing a quantitative approach to physics. His work on acceleration and parabolic trajectories laid the foundation for classical mechanics. Bonaventura Cavalieri was an important precursor to integral calculus. He developed the method of indivisibles, which allowed mathematicians to compute areas and volumes in a way that anticipated the integral. His ideas strongly influenced later work by Newton and Leibniz. Nocollo Tartaglia was an early Renaissance mathematician who solved specific types of cubic equations, which he reluctantly shared with Cardano. He also worked on problems in ballistics and translated classical works, such as Euclid's Elements, into Italian. American mathematicians became global leaders in the 20th century, particularly in applied mathematics, computer science, statistics, and game theory. Their work is characterized by innovation, collaboration, and interdisciplinary research, with figures like Claude Shanon, John Nash, and Norbert Wiener driving technological and theoretical advances. John Nash contributed to mathematics through his work in game theory, particularly the Nash equilibrium, which analyzes strategies in competitive situations. His ideas are widely used in economics, politics, and decision-making. Claude Shanon founded information theory, introducing the concept of the bit and creating the foundation for modern digital communication, data storage, and computing. George Dantzig developed the simplex method for solving linear programming problems, which is essential in optimizing processes in business, industry, and logistics. Swiss mathematicians, despite the country's small size, made profound contributions, especially in calculus, number theory, and mechanics. The Bernoulli family and Leonhard Euler stand out for their analytical genius and development of mathematical notation and formulas still used today. Leonhard Euler, born in Basel, Switzerland, is widely regarded as one of the greatest mathematicians in history. He made groundbreaking contributions across various fields of mathematics, including calculus, number theory, and topology. Euler introduced the famous Euler's formula and the elegant Euler's identity, considered one of the most beautiful equations in mathematics. He was instrumental in developing modern mathematical notation, including the function notation f of x, the summation symbol, and the use of I for the imaginary number. Euler also laid the foundations of graph theory and made significant advances in mechanics and astronomy. Jacob Bernoulli was one of the earliest contributors to probability theory. He is best known for formulating the law of large numbers, a key concept in probability. His work Ars Conjectandi, published posthumously, is a foundational text in the theory of probability. He also studied exponential growth and compound interest, and introduced the Bernoulli numbers, which later became important in number theory and calculus. Jacob's mathematical legacy influenced generations of mathematicians, including his own family. The younger brother of Jacob Bernoulli is Johann Bernoulli. He made major strides in the development and spread of calculus. A staunch supporter of Leibniz's formulation of calculus, Johann solved the brachistochrone problem, which became foundational in variational calculus. He conducted in-depth studies in differential equations and mechanics. Johann also served as a mentor to Leonhard Euler, shaping the direction of mathematical research for years to come. Daniel Bernoulli, the son of Johann Bernoulli, is best known for his work in fluid dynamics, particularly Bernoulli's principle, which describes the behavior of fluid flow and underpins much of modern aerodynamics and hydrodynamics. He also contributed to probability theory, statistics, and the kinetic theory of gases. Daniel applied mathematical concepts to a variety of fields, including medicine and economics, showing the power of mathematics to solve real-world problems. Gabriel Cramer, born in Geneva, is most famously known for Cramer's rule, a method for solving linear systems using determinants, which remains a fundamental part of linear algebra education today. He also worked on algebraic curves and contributed to geometry and mathematical physics. His work provided a clearer understanding of solutions to polynomial equations and their geometrical representations. Johann Heinrich Lambert made monumental contributions to mathematics, particularly through his proof that pi is irrational, marking one of the first such rigorous results. He also worked on hyperbolic functions and was among the pioneers of non-Euclidean geometry. Lambert's work extended to map projections, creating the Lambert conformal conic projection, widely used in cartography. German mathematicians were deeply involved in developing the foundations of modern mathematics. They emphasized formalism, structure, and logic, contributing to algebra, set theory, and geometry. Gauss, Hilbert, Riemann, and Noether exemplify the German tradition of intellectual depth and mathematical rigor. Carl Friedrich Gauss is famously known as the Prince of Mathematicians. He made groundbreaking contributions across various fields, including number theory, where he developed modular arithmetic and early forms of the prime number theorem. He also introduced Gaussian elimination, contributed to non-Euclidean geometry and complex analysis, and created the normal distribution curve used in statistics. His work extended into astronomy and geodesy, applying mathematics to physical sciences. Bernhard Riemann introduced Riemannian geometry, which later became a key foundation for Einstein's theory of general relativity. He proposed the Riemann hypothesis, one of the most famous unsolved problems in mathematics, and made significant contributions to complex analysis, including Riemann surfaces and the Riemann integral. Gottfried Wilhelm Leibniz is celebrated as one of the co-founders of calculus, independently developing it around the same time as Isaac Newton. His notation for calculus is still in use today. Beyond calculus, Leibniz pioneered the binary number system, a foundation of modern computing, and made early contributions to logic and mathematical philosophy. George Cantor worked primarily in Halle, Germany. He is the founder of set theory and introduced the concept of different sizes of infinity. He distinguished between countable and uncountable infinities, created the diagonal argument, and developed the Cantor set, all of which revolutionized the understanding of infinity and mathematical logic. Indian mathematicians, both ancient and modern, have displayed remarkable intuition and originality. Ancient Indian scholars introduced concepts such as zero, negative numbers, and infinite series long before they appeared in the West. Aryabhata is considered one of the earliest and most influential Indian mathematicians and astronomers. He is best known for introducing the concept of the place value system and using zero as a symbol, which laid the foundation for modern number systems. Aryabhata also accurately calculated an approximation of pi and made significant contributions to trigonometry, including trigonometric tables and methods for solving quadratic equations. Brahmagupta made groundbreaking advancements in algebra and number theory. He was the first to treat zero as a number, defining its mathematical properties and rules for operations involving zero and negative numbers. His work also included methods for solving indeterminate equations and formulas for geometric problems, such as calculating the area of cyclic quadrilaterals.